All right, hello, and welcome to part 4 of Griscom and land use land cover change analysis. Quick recap of what happened in part 3 was that we actually derived exactly the polygon of interest for Mozambique using the coordinates they had given to us in some observed format. Not really observed, just the Mozambique local convention. So we have the polygon for Mozambique. We have the polygon for we have the polygon here for the 16,000 hectares that we need to study in Indonesia, and we also have the Griscom geotiff file. So we have everything we need, and let's get going and let's do the Griscom potential analysis using QGIS. It's an entirely new file. First thing I'm gonna do is pull in a base map like Google Maps so that you can see what you load on top of it. Next, I'm gonna pull in the Griscom dataset. Next thing I would need is the polygon from Mozambique. The next thing I would need is the 16,000 hectares polygon from Indonesia, right? So we want to study what is so it's asking for what format I want to convert this RR from, and yes, I want to convert to WGS84, and that should be bringing me into Mozambique. Absolutely. So we have that going, and the last thing we then want to bring in is this 16,000 hectares for Indonesia, and this is supposed to be, if I move to see where this layer is, it should bring me somewhere into Indonesia. And you can clearly see that it's not such a straightforward layer. There are some pieces of land in different parts that are of concern to us. It's all pretty good. So we know our regions of interest. So what I'll first do is go and change the symbology of this into some kind of thick red. I'll change the symbology of this by clicking the layer property into some kind of thick red. And then for this Griscom potential data set, as you can see, it's going from 10,000 to 925 million is the gradations in the value of this data set. Uh, Basically, what you see there is what is considered the reforestation potential, right? And I'll show you the conventions to be able to interpret that, but I just want it to appear slightly different. I don't want it to be in black and white. I'll say single band. I'll change the symbology of this to single band pseudo color, and I will leave the color ramp at going from white until green. So if the potential is high, uh, then it'll be dark green. Potential is low, it'll be white, right? So I'm comfortable with that. So if that is in, I will say okay, and it'll change color to resemble that, which is great. So now let's first focus on Mozambique, right? So let's zoom to layer. Now you see that within this polygon of interest that we're dealing with, there are so many pixels from Griscom where reforestation potential seems to be high in some areas, low in some areas. And this doesn't mean that the forest, that land cover type there is high. It means reforestation potential there is high, which probably means that deforestation there is high, right? So where reforestation potential is high will correspond to where deforestation is high. And we can see that each pixel here is a 750 meter by 750 meter resolution. So if we calculated 750 times 750, you get like 562 500. square meters, which roughly translates into 56.25 hectares. That is the conversion unit. So, and I can show you that by saying that's square meters to hectares. You'll see that each pixel then represents an area of 56.25 hectares. Now, this is something we know about the dataset. Okay, so let's now start with only looking at the potential within Mozambique. So the first thing I'm going to do is something called go to the processing toolbox here. I will choose clip and I want to clip raster by mask layer, right? So I'll tell you what that means. This means that we choose the input layer as the Griscom data set, which is the raster or the geotiff layer we want to clip, and we set the clipping bounds or the mask layer. You get two choices here, as you can see, because there are only two vector layers here, and I will choose RR, which is the Reserva Recreativa and Mozambique as the clipping layer. And when all of that is done, this is actually the internal Python command that's actually going to do the job. GDAL is a library for Python, so this is actually can be implemented on the command line. It can be implemented in Python, but that is the summary of this entire QGIS workflow that we're going to run. So now when we have pressed this, I actually want to create a new layer with the results, and it doesn't really seem to allow for it. So it says clip mask, it's going to save it to a temporary file. Okay, let it do that. So I'm going to run, and then you should see a new layer appear now. It's an entirely new layer has appeared here called clipped mask, and in the end you see that it's a temporary layer only. I quite like, and it's also in black and white because the symbology has not changed. So I'm going to rename this layer as Griscom for the Recreativa region, and I will turn off the underlying base map, underlying the Griscom dataset. I don't need to observe it for all of it. I'll go in here separately and repeat that single band pseudo color so that from the minimum to its maximum, it goes from white to green. So when I do this, you'll see that this is what it looks like within the bounds of Mozambique, of that region of interest in Mozambique, right? Which is great. So now the next thing I want to do, I want to repeat this exact same operation, but for the 16,000 hectares in Indonesia. I'm gonna scroll down all the way, and I don't need to really change anything. I'm gonna hit run. Sadly, it says that it has not generated properly. That means there's a slight problem that we need to address, and I think I know what that problem is. So if I zoom to this 16,000 hectares area, it's so tricky, right? You see that it is such a intricate area that they're showing here, which seems to be tracking some plantations right around the tributaries of a river. So it's a collection of many sites. I'm not sure if this is not what I should be looking at, but I'm going to assume that the data they have sent me is precise and excellent. It does look pretty great, most of the polygons. So it seems like the data is great. So why then are we not able to reduce it to this boundary? One is because there are probably too many elements, too many shapes within the shape, or because there are some open-ended cracks, right? There may be a polygon that's not perfectly drawn, and hence there may be a gap. So actually I'm going to use a slight trick to solve for this, to make it a perfectly completed polygon that won't have any leaks. And the answer to that is I'm going to use a processing toolbox function called buffer. And I am going to actually choose that area itself, and I'm going to draw a buffer around it at a distance of 0 meters. So if you draw a buffer at 0 meters, it's going to be the same. It is going to be the same polygon itself. It's going to create another temporary layer that resembles exactly the same polygon. So I'm going to run this. It's run perfectly. So we're in great shape. It has run and created all these small polygons at a buffer of 0. So I'm going to omit the old one that we had, and I'm going to use this temporary buffer layer as our region of interest. So I'm going to say this is Indonesia, 16,000 hectares. Rename that layer, and now go ahead and once again try to run the raster by mask layer function, where I choose the input layer as Griscom, not Griscom RR, the entire Griscom dataset, NCS dataset. The mask layer is the newly temporarily imported Indonesia 16,000 hectares polygon, and I will save the output to a new temporary layer. Now when I run, I'm hoping that it executes perfectly without an error. And it it has, so we've succeeded. So it clearly looked like that Indonesia shapefile that we got had some holes or leaks, so the algorithm didn't know where to start and stop the clip. But when I've created a 0 meter buffer, now it knows exactly what to do. So we're now working with this clip mask. So this is easy. It's pretty similar to the last one. I'll go and rename it as Griscom underscore Indonesia. That gives us an indication of what it is. I'll get in there. I'll change it to single band pseudo color 0 to white to green. I will hit OK. Looks really nice within those polygons. I'll go change this symbology for just to be a red outline so we can actually look within that. And can you see these polygons are so small that one 750 meter pixel around it is all that it can generate. So 750 meter resolution is really poor for this, and we need a much better data set. So at some point we'll be jumping into, we definitely need the other land cover analysis to be able to make sense of reforestation potential for this region. Griscom is not going to yield a very meaningful result here. I would not encourage using Griscom. Okay, so once again, now we have concluded this being able to generate clipped rasters within our regions of interest. The next step is something called generate a raster layer histogram. Yeah, okay, great, got it. So we got raster layer histogram. We need to be able to create a raster layer histogram for the clipped Griscom layer. There's only one band in the image, so it's that band. And I'm thinking how many bins I need to run this for. I'm quickly going to revisit the Griscom analysis that I've done in the past for other locations. Let's see, maybe I did it for this, for Golquay North. Yeah, this is the Griscom potential analysis that I did, and I think I ran a histogram with 50 bins. Before that, I think I will look at the first time I ran this analysis, which I did in the context of Bukidnon, and that's called Griscom et al. For Bukidnon. Oh, this is an explanatory slide that I gave for them. That's not it. I want to look at how many bins I actually did. Yeah, it's a histogram with 50 bins. So I just need to be able to replicate that. So I'll just say call this Griscom for Mozambique because Mozambique. Okay, so coming back to QGIS, I need to be able to run a histogram for 50 pins. Where do I want to save the histogram? I don't want to save it to a temporary file. I want to save it to a file. So I'm going to come up here, come to the downloads folder, go to Mozambique, and I will save it as rr underscore hist. And it's going to save this as a HTML file within which it's going to show the dynamic histogram as a plotly.js map. I'm going to run this. Great, it's generated the histogram. Let's go look at that histogram now. We saved it under downloads Mozambique RR hist. Okay, this is the histogram, right? So the within that entire Griscom clipped raster within the polygonal bounds of our Mozambique region of interest, there are 400, like this shows me that this chart shows me there are 441 pixels that are in the region of 0 to 10 million. And similarly, like towards the end, you can see that 1270 pixels in the region 900 million to 910 million. That's the way I should be interpreting this chart. Okay, so let me bring one of these sample slides into my Griscom potential here, and I'll be like, call this recreativa, because that's what we're working with now in the context of Mozambique. And I'm going to start piecing up the different parts of this analysis together as we speak. Great. So now I'll look for pieces from some of my other analysis so I can bring it all together. I'm going to need this cover slide. I'm going to need a summary slide for Mozambique. Here we are. I don't need to link that. Griscom et al. 4. Okay, so I'm going to call this Griscom et al. Deforestation control and modus dynamic world and land cover change analysis for the creative region of interest. Creativa region of interest in Ovuro district of Mozambique. We already have the link to the Griscom potential here. Okay, we're going to start piecing this analysis together from the histogram in the next video. Thank you.